Hi, I'm Erin Betts, a propulsion engineer at NASA's Marshall Space Flight Center. I have led and participated in several projects that evaluate how digital design tools and new fabrication processes can improve our ability to build sustainable, affordable space hardware. Before you even start designing a launch vehicle or any large system, it's important to compare several concepts and pick a winner. From a management perspective, you want a concept that not only accomplishes a specific NASA mission, but is affordable and sustainable. New tools, such as video walls, enhance our ability to actually see the design from many angles. Teams of engineers from different disciplines can collaborate. This helps us start with a concept that is already far ahead of the curve. Time is money. CAD models and high-resolution integrated analytical models have become part of the manufacturing process, which helps shorten the time from design to manufacturing for everything from small components to entire hardware systems. 3D CAD models are now being carried from the design and development phase all the way through manufacturing, inspection, test, and operation. 3D models and simulations let us fly through a virtual design of components and entire systems. We can quickly see design flaws and mismatched interfaces. Then we can fix the problems before they become so central to the design that they are impossible or costly to change. Additive manufacturing lets us try out designs early in a product's life cycle. There is no need to fabricate costly tooling that is often required using traditional fabrication methods. It also allows us to fabricate designs that could not have been made before, allowing us to be more creative and innovative. Other fully automated processes, such as robotic welding and CNC milling and water jets, have evolved, making it easier to manufacture prototypes or components quickly and at any time during a product's life cycle. Once you've made a part, regardless of how you made it, you need to know if it is built correctly. Inspection time is also reduced when you use modern techniques, such as structured light scanning, to compare models of what you actually built to what you intended to build. Testing can be used in almost every phase of a product's development. With additive manufacturing, engineers at Marshall were able to build a one-piece injector and get it on the test stand in about a month. This injector was half the cost of an injector built using traditional methods and performed just as well. This quick turnaround testing allows designers to explore and compare the performance of various designs early in a product's development. This saves money in the long run and allows the program to proceed beyond development at a much lower risk and higher fidelity. Virtual 3D simulations reduce the cost and time it takes to evaluate logistics and operations early in the development phase of a system. They also help the ground crew who is training to operate new space systems. In summary, modern digital design tools and automated processes help reduce the cost and time needed to develop complex hardware. The challenge is in using these techniques in a way that aligns with your design space, whether heritage or blank sheet. As we have the opportunity to apply these techniques more broadly, the fidelity of the output will increase. Engineers like me at Marshall Space Flight Center are working hard to take advantage of, develop, and characterize new technologies that will be used to achieve NASA's exciting exploration missions.